Hello guys and welcome to a new tutorial on animation setup for Unreal Engine 5. Okay, the project I'm using here is in the description. You can go ahead and download it if you want to follow along. The project has some basic setup. First of all, there is a player class, which is basically what you're playing. So if you play the game now, this robot, which is from actually the Epic game, is the one you're playing, but there's no animation setup. So you're basically standing still and doesn't do anything. Although you can look around, move around, and jump. The animation assets are already included. If you go to the Paragon Crunch, which is the name of the player, and go to the characters, look for heroes, crunch animation. You can see there is quite a lot of animation already there. So the tutorial is about how do you compose together a animation blueprint that will govern the animation being played for the character. Okay. All right. So back here to the content folder, which is the top folder. Okay. Let me right click and make a new animation blueprint, which is here. I'll call this guy. Oh, you also have to pick up the correct skeleton. In this case, we have only one, right? And create. This skeleton is basically the rig you import into the engine. Let me click on create. And this will be an BP and then player. Okay. Now, to make the player use that animation blueprint, you have to double click to open the player class. And then you have to assign that to the mesh. So grab the mesh. The mesh is basically the mesh, right? The visual of the player character. And you can look for the animation part. The animation mode will be using the animation blueprint. The animation blueprint class then will be the one we created. Okay, compile and save that. Now back here to the animation blueprint, if you double click to open it, you can see now we have two basic graphs, the event graph and the animation graph. Those two graphs will determine what animation will be eventually played. Whatever that goes to the result of the output post of the animation graph will be the final animation being played. Okay, so we can actually test that. If you look for Addo in the asset browser and drag the Addo combat over there and connect that post to the result, compile and save it. You can see now how the animation becomes the Addo one. And if you go back here to the map and play it, you can also see we're basically doing that single Addo animation. Okay, so whatever goes to this final result will be the one being played, and we can create a complicated graph to determine very complex animation changes. So that's animation graph, right? The event graph is basically a place we can lay out some coding to gather information that will eventually tell the animation graph what to do, right? This is basically where we can get things like the player's speed, or is the player in the air or jumping, right? And those information will guide or determine what animation that will be finally flows into the output post, which will determine the final post. That's the basic framework of the animation blueprint. Okay, so apparently we need to gather some important information before we can jump into the animation graph. So let's go back here to the event graph. And by the way, if you don't like setting this up, right, you can just follow it, or maybe I think I have a commit here in the repository I gave you, that there is one that has these guys done, right? But it really helps if you understand how this part works on the basic level. Okay, the first thing I need to do is gather the important information. So which one is the player and the movement component the player is using. So to start with, we can create this node called event blueprint initialize animation. This is the one that's the equivalent of the begin play or start function that will be called when the game starts. And then we can grab that try get pawn owner, which is whoever that uses this animation blueprint. But this is of the type pawn. Our player class is actually based on the character class, which is kind of like a child class of pawn. So we can actually cast it to a character so that we have more information. Because that's the actually the correct type there. We can drag out from the as character and then promote it to a variable, which means that we can always reference it now in the animation blueprint. It is now a member variable of the blueprint. Okay, and then we can also get the character movement all the way to the very bottom. Get character movement. This is the movement component that governs the movement of the player character. We can promote that to a variable as well as we can reference it later. Okay, now those are some important informations. This node called blueprint update animation, it will be called in every update. It's the equivalent of the tick function or update function. Basically, it's called every frame. Okay, and this is where we get real-time update to the player's information. The first thing we need to get is the speed of the player. To do that, let's drag out the as character, which is basically the one we saved in here. Right now, we're dragging it out, and then we can get the velocity. Somewhere down there. Okay, you can grab two nodes and hit the Q button to align them. Okay, and then we can get the length of the vector length, and that will be the speed. The velocity is a three-dimensional vector, right? So it is the direction with the magnitude. The magnitude represents the actual speed of the character, and this is going to be the speed. We can actually promote that to a variable as well, so that our animation graph can reference it. I drag it over there, and let's also grab that variable name and rename it to speed. Okay, now we know the speed of the player. Okay, with that important information gathered, we can now go back here to the animation graph. We can start set up our animation. Okay, because we're blending multiple animations, right? Idle and running and a bunch of in-betweens, we need to have a state machine. So let me right click and type in state machine. I'm gonna call this guy ground locomotion by clicking on the name and then say ground locomotion, and then double click to open it. In the entry, let me drag out and then add a new state. This one will be called idle. And let me double click to open idle and then drag the idle combat once again, right? Drag it over there and connect to the result. Okay, this means that the idle pose is basically the idle combat animation or idle state there. At the moment, there's only one state in the state machine. So basically, if we go back here and delete that idle combat and connect our state machine to the results, we're going to get the same result, because in this state machine, there's only one state, which is the state that's going to be used when we enter that state machine, right? And that state is playing the idle. So basically, we're playing the idle, right? Let's test that. You can see now we're the same as before, right? But now we can add a multiple state to this locomotion here. You can click on this, these tags to go back to those different hierarchies. And you can see how Unreal uses an hierarchical structure, or like a rabbit hole kind of like structure, to organize animation, which could be cleaner when it comes to dragging a bunch of lines and state changes. Let's go back here to the ground locomotion there, and then we can create another state. And this one will be jog start. Okay, and then another state, and this one will be jogging, and then another state. This one will be jog stop. Okay, and then we're going to try to connect those states from idle. First thing we will have to do is to drag from the gray bar of idle to the gray bar of jog start, which will create a transition. You can see how the transition has an arrow, which means the transition will be coming from idle to jog start. You can also see there is a transition rule here. You can double click to open it, and you can determine when that transition should happen. The default setting is not happening at all, right? So in this case, then it's easy to determine. We just need to drag out the speed, because that's the speed we get from the event graph. If that speed is bigger, right, you can drag out from that little green dot and type in bigger than, and then greater than, right? Greater than 0 means we're running, and drag that over to the can enter transition. This is basically saying, hey, if we're moving, let's transition, right, from the idle to the jog start. And from jog start to jogging, and this one should be automatic. We can grab that and then check on automatic. Okay, and from jogging back to jog stop, that's when our speed is 0. So go in there and we can use the speed one more time, and then this one just need to be smaller or equal to, I guess, 0, which means that we are not running anymore. And that will be when we need to transition. Keep on clicking the compile and save here just to make the changes saved. Right, back here to the local motion. And then final thing, from jog stop to the idle, right, we need to use a automatic actually. So grab that and check on automatic, which will automatically transition when the animation is nearing finish from the previous one to the next one. Yeah, that's right. So this is basically the transition we need. All I have to do now is go to the jog start and then populate that with jog start, which the one we're going to use is the jog forward start. Okay, and then for the jogging, I'm going to use jog forward. And then to the jog stop, we just need to use the jog forward stop. You can drag it directly to the result to make that connection automatically. Now we have all these animations, right? If you have the cursor here, you can even see what's in there, right? Although quite small. Okay, so basically we have this graph that when our speed is bigger than 0, does it say 0? Yeah, it's 0. Speed is bigger than 0, then we transition to jog start and we automatically go to the jogging, which is a looping animation. And when we are not running, if our speed is smaller than or equal to 0, we go back to stop and then automatically transition to idle. Right, that's the basic logic. So compile and save it. Go back here to the map. We can go play one more time. You can see now indeed we're playing the jogging and then stopped. And then let me hit the W button to go forward. And you can see we're indeed playing that jogging animation. Release the W button, and you can see we're going to the jog, stopping, and then finally stopped. Okay, but there's a bunch of arrows you can already see. In the beginning of the game, we're playing the animation. That's because we are moving. We're not moving forward, but we're falling down. That's also speed. Indeed, in fact, if I jump now, you can see I'm playing the jogging animation again because indeed we are having a speed, right? So we need to further improve our graph so that we're not jogging when we're jumping. And furthermore, if I'm jogging right now and I stop and start jogging again, you can see that jogging wouldn't start until the jogging stop is completely finished. So there's a bunch of settings we can tweak to make it transition more responsively, because now it is basically having to stop the previous animation before jumping to the next one, which is how the transition works at the moment. But at least now we have some animation changing in the process, right? And then we have the basic setup of the graph. That'll be the first video, right? Next one, we're going to try to improve our moving mechanics. All right, see you guys next time.